Welcome to the Deep Dive. We're your shortcut to getting informed fast. Today we are really digging into creatine. Now, most people hear creatine and, think athletes, big muscles. But what if it's doing way more than we generally assume? We've gone through a heap of scientific reviews, hundreds of studies actually, to get you the real story, our mission. To cut through the usual talk, bust some myths, and show you how creatine really works for muscles? Yeah, but maybe even for your brain. So let's unpack this thing.
Yeah, it's definitely got layers people miss. Okay, so creatine, it's an amino acid derivative. Your body actually makes it liver, kidneys mostly. And you get some from food too, like red meat, fish. But the key thing is 95% of it ends up stored right in your skeletal muscles. Its main job, it's all about the ATP PCR system. That's your body's super fast energy pathway for short, intense stuff. Think lifting weights, sprinting. It helps remake ATP, that's our energy currency, in just, say, 5-10 seconds. It's like an energy buffer, really. Shuttle. Okay, so it fuels those quick, powerful moments.
Exactly. And while we make some and eat some, you often don't get enough to totally max out those muscle stores, especially, say, if you're a vegetarian. That's where supplementation comes in. It pushes your energy system beyond its sort of natural baseline.
Right, optimizing that immediate power. Now, let's talk about that common idea. Creatine and water weight. People picture muscles just puffing up with water. Is that really what's happening, or is there more to it?
Yeah, that's where it gets really interesting. It's way more than just passive water retention. See, that extra water inside the muscle cells, we call it cell volumization, it isn't just sitting there. It actually acts as an active anabolic signal.
Anabolic signal, meaning?
Meaning it directly tells your muscle cells, hey, time to build. It triggers pathways for making more muscle protein for growth. So that initial puffiness isn't just water. It's literally step one in building more muscle tissue.
Okay, that completely reframes it. And you mentioned it's not just muscles. The brain is a real energy hog, right? Uses something like 20% of our energy.
It absolutely is. And creatine plays a role there too. Supplementing can actually increase the creatine levels in your brain. This seems to boost cognitive performance. It can help reduce mental fatigue, especially when you're, say, sleep deprived or under other metabolic stress.
So like sharper thinking, better focus.
Yeah, potentially improvements in memory, attention, things like executive function, and there's more. Creatine also seems to have antioxidant and anti-inflammatory effects. It helps fight off those damaging reactive oxygen species, oxidative stress, and lower some inflammation markers. That helps with recovery, protects cells generally.
Wow. So it helps you push harder, think clearer, and recover better. Let's drill down on the physical performance side. What kind of concrete gains are we talking?
The data is pretty consistent. For strength and power, you're typically looking at a 5 to 15% increase. To put numbers on it, studies often show young guys adding maybe 15 pounds to their bench press max, maybe 20 pounds to their squat max on average. It's noticeable.
That's significant. What about speed or team sports?
Good question. It improves single sprint performance slightly, maybe shaving a tiny bit off a 100-meter time, but where it really shines is in repeated sprints. Think soccer, basketball, hockey stop-start, burst recover. It helps maintain that power output over multiple efforts. And muscle growth, hypertrophy. Well, we talked about the cell volumization signal. That kicks things off. Long-term, it supports actual protein synthesis.
Okay, and you mentioned recovery. What about injury?
That's actually a critical point. It helps reduce muscle damage from exercise, yes. But importantly, it can help preserve muscle mass if you're immobilized, like with a cast. And then during rehab, it helps stimulate muscle growth again, so it can potentially speed up that whole return-to-play process.
That's huge for anyone sidelined. Okay, myth-busting time, the big one. Creatine causes dehydration and cramps. We've all heard it. What's the reality?
Yeah, that one just won't die. But the science is really clear now. It's thoroughly debunked. Study after study actually shows the opposite. Creatine users tend to experience fewer cramps, less dehydration, even a lower risk of heat illness. If anything, it seems to help with hydration and keeping your body temperature regulated.
So the complete opposite is true.
Interesting. That leads to the other big concern. Kidney health. People worry about it. What does the evidence say?
Right. Look, creatine monohydrate is one of the most studied supplements ever. It's incredibly safe for healthy people. We have long-term studies, people taking up to 30 grams a day for 5 years, showing no adverse effects on kidney function in healthy individuals. You might see a small rise in blood creatinine levels, but that's just a normal byproduct of creatine metabolism. It does not mean your kidneys are damaged, assuming they were healthy to start with.
Good to clarify that. So how should people take it? Loading phase? Specific type. The common approach works well. A loading phase, maybe 20, 25 grams spread through the day for 5, 7 days. That saturates your muscles quickly. Then you drop down to a maintenance dose, usually 3 to 5 grams a day. And as for the type, stick with creatine monohydrate. It's the gold standard. Most researched, proven effective, best value. Don't need the fancy, more expensive versions.
Okay, so wrapping up this deep dive, creatine monohydrate seems incredibly solid. It's effective, it's safe, pretty versatile too. Boosts physical performance, speeds up recovery, helps build muscle, and even offers some cognitive benefits, all backed by a ton of research.
That sums it up well.
So the final thought for you listening, if this one simple, well-understood compound can have such a profound effect, not just on strength, but recovery, even thinking, what other basic biological insights might we be missing in our quest for peak health and performance? Something to think about.